Hello guys, welcome to your channel which is SciEngineers. This is Sushant and this is your Mhtcet section for the physics part. So those who are new to the channel, we would like to tell them about the playlist which we have for Mhtcet mathematics section, which has over 50 plus videos in it. So do go through them so that you can have your revision for the mathematics section. We have started recently uploading videos for the physics part and this is your rotational motion. So do like our videos, do share it with your friends and do subscribe to our channel. Do hit the bell icon which is just beside the subscribe button so that you never miss a notification from us. So keep watching our videos, keep learning from our videos. Also stay safe. So let's get going. In the earlier video, we had given you these two questions. So here is a solution for them. So the planet has twice the radius, but the density is 1/4 that of Earth. So let us say that R1 is the planet for whose radius is given. So the planet has twice the radius of Earth. So let us say this R is nothing but radius of Earth. So ρ1 is given as 1/4 of rho. That is, rho is nothing but the density of Earth. Then what is the ratio of the escape velocity? So in the earlier video, we had already discussed the formula for escape velocity. So that is nothing but VE is nothing but equal to root of 2gm upon r. So this is the formula for escape velocity. So I need to find the ratio. So escape velocity of the planet and escape velocity of the Earth is what we need to find. So it is asking us the ratio of escape velocity from Earth to that of planet. So we need the Earth in the numerator and we need the planet. So we can just write it as VE1 in the denominator. So that's going to be 2gm1 and R1. But in this case, they are giving you the density information. So we need to bring down this thing in the density term also. So that is also we had seen in the earlier video how to bring the density term in this. So what we will do is we'll write this as 2gm. We already have the mass. We need the volume in the denominator. So that is going to be 4/3 pi r cube. So the new term which we have introduced is 4/3 pi, and one of the r was already present, so it's nothing but going to be r square. So divided by same thing which will be done. So this entire thing over here is nothing but the density. So we have the formula as root of 2g rho, the 4/3 term pi and r square. So this thing will be divided by the planet's term. So that is 2g. It's going to be ρ1 4/3 pi r1 square. So all the constant terms gets cancelled out. So we have rho by ρ1. So rho by ρ1 into r square. So rho r square upon ρ1, we know it's 1/4 rho, and r1 is nothing but 2r. So that becomes 4r square. So the 4 gets cancelled out and the rho also get cancelled out and it is under root. So we are getting this as 1/1. So that's nothing but the ratio as C, which is 1:1. Going on to the next one, it is telling us that a satellite of the mass m, which is revolving in a circular orbit of radius r around Earth, has kinetic energy as E. Then what is the angular momentum? So when we need to find the angular momentum, we know that the formula which we have to use is L is equal to, so L is nothing but angular momentum, L is equal to mvr. So I need to find the velocity with which it is going to be moving. That we can find it from the kinetic energy term. So kinetic energy E is nothing but equal to half mv square. So from here I can find what is the m. So what we'll do is we'll multiply on both sides by m. So this becomes m square v square. The 2 term goes that side. So we are getting this as mv is equal to 2m e under root. So my mv term is nothing but 2 m capital E and r. So we can take the r inside, so that becomes 2 m e r square. So that's nothing but your option C. So the question states about a body which is having the moment of inertia which is 3 kg per meter square, and it is rotating with an angular velocity of 3 radians. It is said that the kinetic energy of this body is same as that of a body which is of mass 27 kg, and I need to find the velocity v of that particular body, which is basically having translation motion. So you have to assume that the another body which is of 27 kg is having translation motion to it. So what it is telling us is that the kinetic energy of rotation is equal to kinetic energy of translation. So kinetic energy of rotation is half I omega square, and is equal to the translation motion of the second body is nothing but half m v square. So from this you can see half gets cancelled out, and I need to find what is the velocity v. So v is going to be nothing but root of, it's going to be I omega square by m. So we need to just substitute the values. We have the I as 3, the omega as 3 square, and the mass as 27. So that's nothing but 9 3s are 27, which gets cancelled out, and it's nothing but root of 1. So answer is nothing but A. Moving to the second one, we have a thin circular ring of mass m, and its radius is r. It is rotating about its axis with an angular velocity of omega. Two objects which is of mass m, capital M, are attached to it gently. That means basically there is no jerk which is present. It is not disturbing the system. It is attached on the opposite end of the diameter, and I need to find what is going to be the new angular velocity. So the basic concept which we have to understand over here is that this conservation of momentum. So that means the initial, that is, let us say I1 omega 1 is equal to I2 omega 2. So I need to know what is I1. I1 is nothing but about the thin ring, circular ring. So moment of inertia of the circular ring is nothing but mr square. So mr square omega, because omega is what is the angular velocity given, is equal to I2. So I2 is nothing but the moment of inertia of the ring plus the masses which are attached to it. Now these two masses, we can see that this is my ring, and they are attached diametrically opposite to each other. So they are of mass m, capital M, and the distance between them is r from the center. So the moment of inertia of this mass is going to be mr square, and about this mass is also going to be mr square. So the total moment of inertia, that is after it is being attached, is going to be small mr square, which is the rings, plus it's going to be capital mr square, so 2 times capital mr square. So this is what basically the concept is over here. So we'll just substitute I2 as m plus 2m r square, and this is my omega dash, which is the new angular velocity. So r square gets cancelled out, so I find that my new angular velocity is nothing but equal to m into omega divided by m plus 2m. So by mistake I have done this as capital M. It should be small m, because that's the moment of inertia of the ring. So it's small m omega upon m plus 2m. So that's nothing but your option D. Coming to the third one, we have a solid sphere which is of radius r and has a moment of inertia I about the geometrical axis. So there it is talking about a sphere, and about this center it is having the moment of inertia as I, and its radius is given to us as r. Now it is melted, so this basically we are making a new shape now, which is a disk of radius small r. So we have a disk of radius small r, and its thickness is given to us as t. So it's basically, we can assume that the disk is nothing but a cylinder. Its moment of inertia about the tangential axis, which is perpendicular to the plane of the disk. So it is perpendicular to the plane, and it is tangential, so it is talking about this particular axis, is equal to I, then the value of R is. So it is telling that the moment of inertia of this and the moment of inertia of this thing is same. So we know that if I want to find the moment of inertia about this center passing through the center, it's half mr square. Since the same sphere, that is the volume of this, is equal to this, and basically the mass is also going to be same because the amount of mass is not changing. So it can be the moment of inertia about the center is half mr square. Now using your parallel axis theorem, we need to just add mr square to this, so that becomes the moment of inertia about this tangential axis which is required is going to be half mr square plus mr square, which is 3 by 2 mr square. So now we need to just equate this moment of inertia with the moment of inertia of the sphere, and we know it is given by 2 by 5 mr square. So we need to just equate this thing. So over here we have to consider this radius as r, small r, so that's going to be small r. So we will be getting the equation as 3 by 2 m small r square is equal to 2 by 5 capital M capital R square. So now the M gets cancelled out, now cross multiplying, and R, so we'll be getting R as root of, the 2 goes there, so that becomes 4 by 15 R. So that's nothing but 2 by root 15 R. So that's nothing but option A. Moving on to the fourth one, we have 3 identical spheres of mass M. Each are placed at the corners of the equilateral triangle. So let us consider this to be an equilateral triangle. And one of the corner is taken as origin. So we can consider this as the axis, and this is my mass M, which is present at this point. So we can the coordinate for this is going to be 0, 0, because we need to find the center of mass of this particular system. So I need to find what is the coordinate of this. So they have given the distance as 2. So we can easily find the coordinate of this, which is going to be 2, 0. Now going for this one, we know that it is going to be halfway because this is an equilateral triangle. So it is forming a 30, 60, 90 triangle. So this distance, which is opposite to 30 degrees, is half the hypotenuse. Hypotenuse is my 2. So this distance is 1. And this distance is root 3 by 2 times the hypotenuse. So it becomes root 3. So the coordinate of this point is nothing but 1, root 3. So now I need to find the center of mass. So the center of mass we can calculate by x bar is equal to the x, the position of the x into the mass M. So it's going to be 0 into M, plus it's going to be, for this particular point it is 1 into M, and for this point it is going to be 2 into M, divided by total mass. So it's of 3M because there are 3 spheres. So if I calculate this, I get this point as 1. Now coming down to the y bar is going to be nothing but again the masses into the y coordinate. So again y coordinate for this is 0, so 0 into M, plus it's root 3 into M, and for this also the y coordinate is 0, so 0 into M, divided by, it's again 3M. So the calculation we get it as 1 by root 3. Now they are asking us in the ijk form, ij form. So we know the unit vector about x is I, and the unit vector along the y is j. So you can see it's of this particular form, that is 1, 1 by root 3, that is I plus j by root 3, that's D. Coming down to the next question, we have a ball which is rolling without slipping, and the radius of gyration is given as k, and the radius of the ball is given as r. Then what is the fraction of total energy to the rotational energy will be? So we need to find what is a fraction of which the rotational energy will be. That is, we need to find the kinetic energy of rotation divided by the kinetic energy of rotation plus kinetic energy of translation. That's the concept which we need to use, because total energy is nothing but addition of rotation plus translation. Now the kinetic energy of rotation, so that's given by half I omega square divided by the rotational half I omega square plus the translation is given by half mv square. So you can see that the half gets cancelled out, and also along with that we know that v square is nothing but omega square r square. So this becomes omega square into r square. So omega square also cancels out. So we are landing with the term which is I upon I plus m r square. Now in this we know that I is nothing but equal to mk square, because you can see from the answers we have the k term and we don't have the I term present. So we can introduce the k term, so mk square, which is nothing but k is nothing but the radius of gyration. So mk square plus mr square. So the m gets cancelled out. So we are landing with the term which is k square upon k square plus r square, which is nothing but your option. So as you all know, for practice we also provide you certain sums. So these are the two sums for this particular video. You can just go through it, try it out, and post in the comment section what you feel the answer should be. So these two sums are related to what we have already done, so this will be just practice for you. The solution for this will be provided in the next video which will be coming. So thank you guys for watching our videos. Do let us know in the comment section how do you find the new section which we have started, which is for the physics section. Do let us know in the comment section also what more videos you would like us to cover, what more topics you would like us to make the videos on. Also, please do like our videos, please do share our videos, and do subscribe to our channel. To never miss a notification from us, hit the bell icon. So keep learning, keep watching our videos, and happy learning, and stay safe. So bye.